Hi class, this is Sir Alex. Welcome to our lesson in Physics 1. This is lesson 3.1 and today we'll be talking about the kinematics of translation. We'll be focusing on displacement, velocity, and acceleration. So we'll begin by first discussing what our goals for today's lesson. So the goals for our today's lesson is for us to be able to understand what is motion, as well as to differentiate between kinematics and dynamics. We also want to be able to explain what is frame of reference, as well as distinguish the difference between velocity and speed. Moreover, we want to distinguish what is average speed or velocity and differentiate it from instantaneous speed and velocity. Lastly, we want to be able to explain what is acceleration. We'll begin our discussion by first talking about what is motion. Motion is basically the most normal and the most common phenomenon that you can observe, or one of the most common phenomena that you can observe a person is doing. Motion is basically when a person, a body, or something, an object, changes its position over time. So, an example, you waking up from your room and going to the living room. So there's a position change from your bedroom going to your living room. That is an example of a motion. When we talk about motion or study motion in physics, we usually divide this into two subjects. One is kinematics, wherein we talk about or describe motion along a straight line. Here in kinematics, we do not yet consider the forces acting upon on the object. Hence, we are not going to discuss about force or gravity or weight in this scenario. Dynamics is when we start to focus on the forces acting on the body, which results in the body moving. Okay, so in kinematics, we're only talking about the straight line motion of the object. One of the things that you can see a person do when they move or when they are in motion is, for example, walking. Other is when they're riding bicycle, or when they're in a jeepney or driving their car. All of these are an example of motion. Next, let's talk about frame of reference and position. When we talk about position, it's basically the location an object is in. So, for example, the position that someone is in, a doctor is maybe in the hospital. So it's basically talking about the location at a certain point. Moreover, when we talk about position, there should be a point of reference. When we talk about point of reference or frame of reference, it's basically a physical entity. It could be a person, it could be a place, it could be something, an object, on which the motion or the position is being referred. Here's a funny meme or a meme about frame of reference. And sometimes, in the frame of reference, for one person, something may not be moving while it is moving for the other person. What do we mean by that? An example, the passenger beside you may not be moving in the jeepney. So, meaning, while you are inside the jeepney, the person beside you, as you observe them, you notice that they may not be in motion. There's no change in their position. But for someone outside the jeepney and watches the jeepney and both of you moving, that passenger beside you is in motion. That is the point of reference. So the subject is the passenger beside you. So let's use this pen right here. So the object is the passenger beside you. But for you, this person, your point of reference, for you, the passenger is not moving. But for the other person, someone outside, another point of reference, this person is in motion. That is an example of a frame of reference. Another example is the bathroom, which is the subject, maybe 2 meters away from the kitchen. Kitchen is a point of reference. So for the kitchen, Bathroom is only 2 meters away. But for the living room, another point of reference, the bathroom is 4 meters away. So meaning the position or the motion is actually relative when we talk about motion. And this is something that is important more later on when we talk about relative velocity, etc. Okay, but I hope this is clear. The point of reference is the person that is observing the subject, or it could be a person, it could be a location, it could be an object. Okay, next let's talk about distance and displacement. What is the difference between the two? When we talk about distance, is basically the actual length traveled by the person or moving object, and means this is the total length uh, from the initial position to the final position. Displacement, on the other hand, is a straight line from the original position to the final position. In displacement, we are also considering the direction of the displacement in relative to the final position. What do we mean by these difference? Um, is this picture right here. The red line is the distance. As you can see, in distance, we are considering all of the length traveled or taken by the person or the object moving. While on displacement, we are only recognizing the straight line between the original position A and the final position or final destination B. So when we solve for distance, it is different when we solve for displacement. Again, distance, we are looking at the length of all the path taken by the object. So we are considering all the length or all the how far the person traveled. But for displacement, we are only considering the straight line as well as the direction relative to the final destination. This makes distance a scalar quantity because we're only focusing on the magnitude or the length, while displacement is a vector quantity because not only we are focusing on the magnitude or the length of the straight line but also the direction. We can differentiate between these two by doing this sample problem right here. So let me just okay, move here. Okay, so our sample problem. Suppose that in going to school, you walk 14 meters east and 30 meters north. What was the total distance that you walk? And B, what was your total displacement? Then the next part, after arriving at the school, you found that classes were suspended, and then you walked back when you went walking back home, taking the same route that you did going to school. Then the next question would be, what would be the total distance that you walk from home from school to back home? And then what is the total displacement that you walk from home to school and school to home? So in order to answer this, let's do our given ask solution, a formula solution format. Okay, so let's first write what our given. So we were given two lengths. One is 40 meters east and second is 30 meters north. So we first walk 40 meters towards east and the second part is 30 meters going north. Then what they were asking us is A, what is the total distance that you walk? So what is the total distance from home to school? On B, they're asking what is the displacement. In our class, we'll use a small letter d when we talk about distance and capital D when we talk about displacement, so you guys won't get confused. from home to school. So the displacement from home to school. Next is, again, what is the distance? But again, this is asking from home to school and then going back home. And lastly, it's asking the displacement from home to school and then back home. And then next is the formula. I'm not going to write anything yet on the formula because I'll show you later how we're going to solve this. And I'm going to show you using solution. Okay, so let's try to solve A. In A, it's asking the distance when you went from home to school. As discussed earlier, distance is the total length traveled from the initial position to the final position. So the initial position here is the home, while the final position is the school. Correct? Oh, not school, that is what I meant to write is final. Okay. So how do we solve for the distance? It's easy. What we just have to do is add the two lengths together. 40 meters plus 30 meters. As you can see, we do not yet consider east and north because in distance we do not need the direction. So the total distance traveled is 70 meters. Oh, that's it, 70 meters. Next, let's talk about or let's solve for the displacement from home going to school. Again, home is our initial and school is our final destination. So how do we solve this? Since displacement is a vector and we have two direction and two magnitude and direction, and so in order to solve this, we have to consider both the magnitude and the direction. So let's try to draw this. So the first one is we are going east, correct? And the distance that we traveled is 40 meters going east. And the next part is we traveled going north for 30 meters. Okay, so then how are we going to solve for displacement? Since this is our home right here, and this is our school, this is the final destination, and this is the initial destination. What we just have to do is draw a line, a straight line, because displacement is a straight line from the initial to the final destination. And this is our displacement. As you can see, as you have probably noticed by now, it's basically a right angle. And in order to solve this, we just have to use the Pythagorean theorem. D squared is equals to 40 meters squared plus 30 meters squared. You have to square both sides, and the distance is actually 50 meters. And that's only the first part of our solution, because now we have to solve for the direction relative to the final destination. In order to do that, we have to find the angle. So how are we going to solve for the angle? Simple. We have to use SOHCAHTOA. So let's solve our angle here. SOHCAHTOA. You can use anything, but in my case, let's say I'm going to use tangent. So tangent angle is equals to opposite over adjacent. this case, my opposite is 30 meters and my adjacent is 40 meters. So tangent or angle is equals to arctan multiplied by 30 meters divided by 40 meters. And the angle is actually about 36.87 degrees, right? So our angle is 36.87 degrees, and this is going north of east. So our whole displacement is actually 50 meters, 36.87 degrees north of east. So this is our whole answer right here. Okay, so that's how we use displacement, how to solve for this displacement. Next, let's measure C. So for C, what is the distance from home to school to back to home? So home become the initial and become the final destination. So how are we going to solve this? Simple, the same thing, we just have to add all the directions. So when we were going home to school, we first walked 40 meters plus 30 meters. And then when we went walking from school to home, we traveled another 30 meters and then another 40 meters. In the end, our total distance is 140 meters. Correct? So that's it. Next, let's talk about displacement. So what is the displacement from home to school to home? Again, home is the initial and home became the final destination again. So what is happening here? So well, if you guys just think about it, displacement again is the straight line from the initial position to the final position. So when the initial position is the same as the final position, displacement is basically 0 meters. Because there's no straight line between the two. So if this is your first, correct, this is your first displacement, when you went back home, you did the same thing. You went here and then went to that. And then so that's your displacement the second time, and this is your displacement the first time. So you can see it's the so you start where so you ended up where you started. So in the end, the displacement is 0 meters. So that is the difference between distance and displacement. So I hope that's clear. Let's go back to our slides. Okay, next let's talk about speed and velocity. What is the difference between speed and velocity? When we talk about speed, speed is basically the distance of a body, the distance the body moves in a unit time. So it's simply distance over time. How about velocity? What is the difference in velocity? Velocity in this time is we are considering the direction. So for velocity, it's not only the distance, but it's the displacement of a body per unit time. Hence, making speed a scalar quantity and velocity a vector quantity. Note that the speed or the magnitude of the speed is basically the magnitude of the velocity. Next, let's talk about average speed. Average speed is the total distance divided by time spent that's supposed to be spent in traveling the total distance. In real life situation, speed often change. It's not always that a person is traveling at a specific constant speed. Sometimes they're traveling, let's say, 3 meters per second, or then they move from 3 meters to 5 meters, and then they move again to 7 meters, and then back to 3 meters. In order to get the average speed, you just have to add all of those changing distance and then divide it by time. Okay, add all of those distances and then divide it by whatever how many distance you have or speed you have, and that's how you get the average speed. So average speed is basically equals to total distance divided by the total time, or v is equals to delta d divided by delta t. If the initial time in position is 0, then v is equals to distance over time. What do we mean by this? Okay, so the delta t is equals to the initial minus the final. The same thing, delta t is equals to the initial minus the final. Or wait, my mistake. Okay. Delta d is actually equal to the final minus the initial. Delta time is equals to time final minus the initial. If your initial time is 0, meaning this is 0, this is 0, then d is equals to the final distance and t is equals to final time, meaning velocity or speed is equals to distance over time. Next, instantaneous speed. So what is instantaneous speed? So instantaneous speed is the speed at a particular instant of time, where delta time is extremely small. What do we mean by this? Like I mentioned earlier, let's say this is a person walking. And in the first speed, they are walking 3 meters per second. And then in the next speed, they're walking 5 meters per second. And then in the third time that they're walking 7 meters per second. Correct? Now, average speed, you have to add all of these total distance, the sum of all distance, divided by all the time. The sum of all this time, or the speed, seconds. But for instantaneous speed, we are only looking a fraction of time. For example, this portion right here, this 1 second right here, is instantaneous speed. This is another instantaneous speed. We are looking at a smaller time, not the whole time. So that is basically the difference between the two. This is instantaneous speed. The speed at this instant is 7 meters per second. The speed at this instant is 5 meters. The speed at this instant is 3 meters per second. Let's erase all of this. Okay, next. So what is average velocity? It's basically the same with average speed. If average speed, we have to total all distance. In average velocity, we have to total all displacement. And instantaneous velocity is the velocity at an exact, very specific time. And the average velocity is equals to total distance over total time. And again, if the initial displacement is 0 and the initial is equals to 0 and the initial is equals to 0, then v is equals to distance, or velocity is equals to distance over time. So you can see I just used v because most of the time we'll be talking about velocity anyway. So I don't want to confuse you guys anymore further, so let's just keep using v when we talk about speed or velocity. Because again, speed is basically the magnitude of velocity. For most of the time, we'll be referring to instantaneous velocity and instantaneous speed when we talk about velocity and speed. So most of the time, we'll just be talking at a very specific time, not the average, so that we do not have to compute all the changing times. You just have to focus on a singular instant. And well, that's the speed that we'll be focusing about. Next, let's try solving distance and velocity using the sample problem. Every morning you jog around the 250 mark track 4 times in 30 minutes. What is your average speed and then what is your average velocity? So let's go back to our Microsoft whiteboard here. So open this. Okay, let's see how are we going to answer this question. So here it says every morning you jog around 250 meters track 4 times. So remember that, 250 meters for 30 minutes. So now let's write our given. So the length of the track is equal to 250 meters. And the time they gave us is 30 minutes. Okay, next, what are they asking us? First is the average. First is the average speed, and then B is the average velocity. Okay, formula. We know that V is equals to distance over time for speed, or V is equals to the displacement over time. Okay, next let's do the solution. Okay, so what we have to do is for average speed, we know that the average speed is the total distance divided by the total time. And we usually use meter per second. So the total distance that we have should be 250 meters multiplied by 4. We have to multiply it by 4 because we walk it 4 times. Remember? So 250 meters is equal times 4 is equals to 1000 meters. Next, the total time is 30 minutes. Since we use seconds to measure the speed, we have to change it to seconds. So there's 60 seconds in 1 minute. I hope you guys are comfortable converting units. So that's 1 minute, cancel the minutes. So basically 30 times 60 is equals to 1800 seconds. And then we have to use speed is equals to distance over time. So that's 1000 meter divided by 1800 seconds. So the average speed the person you jog around is about 0.6 meters per second. Next, how are we going to solve for average velocity? As you can see, you run the track 250 meters 4 times. So if you have a track, so let's say this is the start, and then you ran, that's 1, and then you run again, that's 2, 3, 4. You run 4 times. And as you can see, the initial position is the same with final position, which means our displacement is 0, which means our velocity is 0 meters per second. Okay, so I hope that's clear. That's the difference between the two. Again, this is displacement. So it's the straight line. So for example, if you start here and you ran, let's say, 2.5. So you run once, you run twice, and then 2.5. You run again, but this time only until here. So for the displacement, it should be this distance right here, the straight line from the start to your last position. Okay, and then if that's the case, then you have this. You have velocity, but here you don't have velocity because your displacement is 0. Okay, I hope that's clear. Let's go back to our PowerPoint. Okay, next, acceleration. What is acceleration? Acceleration is basically the change in velocity with respect to time. And since velocity is a vector, acceleration is also a vector quantity. There are 3 ways to change velocity. One is when we change speed. Second is when you change direction. Again, since acceleration is vector, there's speed and there's direction. Or the speed, again, is the magnitude of velocity. So change in the magnitude is equals to change in speed, or change in the magnitude of velocity is basically change in speed. So change in speed means you're accelerating. Change in direction means you are accelerating as well. And the third one is you're both changing speed and direction. Then you are accelerating. Hence, an object is accelerating when it is changing speed, has constant speed but is changing direction, and when it is changing its speed and it's changing its direction. When we solve for acceleration, we use change in velocity divided by time. And as you can see here, velocity is what? Meters per second. Time is second. So acceleration, the unit should be meters per second, which means meters per second squared is your units for velocity. So let's have a sample problem right here. In which case is the car accelerating? A car changing lanes at constant speed. A B, a car speeding in an effort to beat red light. C, a car slowing down while making a left turn in a car going roundabout at constant speed. So is the car accelerating when it changed lanes? So since it changed lanes but it's a constant speed, there's no change in speed but there's change in direction, means acceleration is happening. A car is speeding, so there's change in speed in an effort to beat red light. There's a change in speed, then this is accelerating. A car is slowing down, so there's a change in speed while making a turn, and there is a change in direction. Acceleration is happening. A car is going a roundabout. If you guys are not familiar what a roundabout is, it's basically a rotunda. A car is going around, so there is a change in direction, but there's no change in speed. Still, acceleration is happening. So in all 4 scenarios, the car is accelerating. So that's how you solve this problem. Okay, so I hope that's clear, and I hope you guys can distinguish now the difference between velocity, speed, distance, and displacement, and you have an idea what is motion, kinematics, dynamics, and what we call frame of reference, as well as what is acceleration. I hope you guys have a great day and see you guys later on.